homepage. Okay, so this is what it looks like homepage wise on Canvas. Okay, it sort of has a sort of a cover picture, our statistics, my email address, and our syllabus from what I gave out the first day of semester. But right here on the side, it says things to do. Right, so it means you have the following homeworks due today. So this will allow you to submit your homeworks on here. So you'll see them on here. So you just click on the appropriate homework. So section 5.2, okay. It's a file upload kind of homework, which is what we've been doing, right? So you're just turning in a file. The only difference is you now have to upload it instead of turning it in class. Let me see if I can do it myself. Okay. By the way, if your mics are not mute, okay, go ahead and do so. Okay. Han, pakipatay mo ka TV. Again, you can unmute yourself if you have questions. You can also type your question on the chat. Okay. Um, and so this is what it looks like. Daddy, yeah. Daddy. And so, so if you scroll down, where's the? You can hear my kid saying, "Daddy." Oh, right here, submit assignment. I was trying to see where the scroll bar was. So just click on this, and then you'll have it right there at the bottom. Just upload the file, right? So choose the file. That's why I ask you to download a scanner app. So that way all your apps, all your pictures are in one file and it becomes a PDF file. And it's easier for me to grade because I'll be able to write on it if needed. And that goes with your test as well. Okay, so you basically just choose a file. In this case, I don't want to turn in anything from my side. But that's just once you have the file in there, just click on submit assignment and you'll turn basically 5.2 in online. Okay, so this is how you are going to turn in your homework assignments. Okay, any questions on that? So let me leave here. Okay. So you have these upcoming assignments, right? So you have it here. Again, depending on what we finish today, really in Wednesday as well, you'll have your um, sort of what sections are due next week. Okay. But any questions on how to turn in homeworks?
It says there 5 point. Well, it says all of that's due today. Is that wrong or?
No, because we did them last week.
Oh, okay. Last week?
Or no, well, 3 weeks ago, I guess.
Oh, okay.
Yeah, so like it's the week before we had spring break. So we
Okay.
finish all of these sections, and
That's
then
today.
typically whatever we finish is due Monday,
Oh, okay.
right? So it's the same thing, right? So that's not going to change. So whatever we finish this week, that will be due Monday, and then you turn them in online instead of physically giving it to me.
Okay.
Okay. Anything else? Any other questions? By the way, just to let you know, this is being recorded, right? So all live lectures would be because it will be uploaded on YouTube in case you cannot make the live lecture. I will post the link on Canvas. Okay. And so, but again, if you want to go over the lecture again, right? And so you have that option as well. Okay, if you choose to do so. But I'm just letting you know that this is being recorded. Okay. Um, as far as sort of the lecture is concerned. Okay. Why? Okay. Anything else? All right. Now, speaking, you can also type in your question on the chat. Okay. The extra credit's still going to go on. The Math Success Center is going to be open online. So they will be answering questions. The only difference now is I don't think there is a workshop. So there will not be any workshops being held, at least temporarily, until they sort of um, get all the tutoring sort of going first. So that's sort of the main concern right now, is to make sure that the tutoring is running properly. Um, so there will be no workshops anymore, but there is still one-on-one tutoring. So that one-on-one tutoring um, will still be valid. You just have to keep track of when you show up for one-on-one tutoring, and essentially who your tutor was, and so on and so forth. We haven't really finalized, or I haven't seen yet how they're keeping track of the hours. Um, but the extra credit is still possible because they're still doing one-on-one tutoring. Okay, just no more workshops and no more learning groups, obviously. Okay. Anything else? Now, speaking of your next test is next week. It would be on Wednesday. Okay. So we'll have your test on Wednesday. I think we should finish all of chapter 6 today. 6.1 and 6.2. We'll see how fast we go. Um, but um, we are going to have your test um, next week on Wednesday. We'll probably spend a few or maybe half the class on Monday to sort of answer questions. Normally, we'll have a review, but since we can't really break into groups, it's kind of hard to do that. Um, Sort of review as a group and do problems. And so we'll have to sort of just make do with sort of a question and answer kind of review next Monday. Okay. Any other questions? So I'll be emailing the study guide probably tonight after our class. Okay. And so, yeah, I think actually if we have time today, we'll go over the outline that I am going to send out to you um, by the end of today. Okay. Anything else? Any other questions? Okay. All right. So let me close this one. Okay, so let me close that. Okay. Let me just do something real quick. All right. So our topic for at least the rest of the way, at least the next couple of sections or chapters, I should say, is more probabilities. But this time, we're going to focus more on probabilities involving quantitative variables, right? So this times our variables, in essentially our events that we are interested in as far as for probability, will involve numbers, right? So we are talking about your variable equaling a certain value or sort of falling within a range of values. And so that's what we're after um, for the next couple of chapters. And so, um, so 6.1, okay, is called discrete random variable. And so we've done variables before, right? So we talked about what a variable is. So I actually asked that on your first test. So variable is essentially the characteristic that you are essentially studying. And so now we're going to focus more on quantitative variables, right? So meaning numerical variables. And in this case, chapter 6 focuses on discrete. So discrete essentially, the formal definition is that your numbers are countable. And that's sort of the mathematical definition of countable. At least for us, at least as for us, our class is concerned, discrete will pretty much mean whole numbers. Okay, so your variable is going to take on a whole number value. Okay, and so that's what we're going to be focusing on. So let's first talk about what it means to be a random variable, because we already know what discrete means. So the question is now, what does it mean to be a random variable? So a random variable is essentially a variable whose value is determined by the outcome of a random experiment. Okay. So essentially, you run your experiment, and obviously the result would be a single value, right? So that's the idea. And so when your experiment sort of is run, you're gonna get just one outcome, right? And we've talked about this before as well. And so here's some examples. So example number one. Okay. And so let's say our experiment okay, is essentially tossing a coin um, 6 times. Okay. So that's our experiment. Now, remember, we are talking about numerical here, right? So it has to be a number. And so you're going to have to define what your variable in this case is going to represent. And so in this case, since it is now going to be a number, we can now use sort of our variables that we use in algebra, typically x. And so we can now use x on this problem. So x is equal to the number of heads. Okay. So note your experiment is not done until you toss your coin 6 times. So you're gonna toss your coin 6 times, and essentially you're gonna count the number of times heads comes out. And so for this particular problem, x will have what values? And you can either
It
say
would
the
have
answer,
like 1 through 6, wouldn't it?
not just 1 through 6, because it is possible to get all tails. So which means what? So it's not just 1 through 6, 0 through 6, right? So it would be 0, 1, 2, 3, 4, 5, and 6. So those are the possible outcomes of your experiment. And notice the outcomes are numerical. Okay. So they are going to be numbers, even though, tossing a coin, you get heads or tails. In this case, we are counting the number of heads, and that gives us um, a random variable. Okay. Any questions? Note it's also discrete, right? Because there's no way to get 2.5 heads, right? So you cannot have half a head, right? So when you toss a coin, you can't have half of that, right? So it's either 0, 1, 2, 3, 4, 5, or 6, right? So that's the first thing. So they are discrete. Second, they are disjoint, right? So it is going to be disjoint, meaning I cannot have, so if I run my experiment, right, I toss a coin 6 times, I cannot have 3 and 5 to happen at the same time, right? They are disjoint, right? So meaning it's either I get 3 or I get 5, but not both of them at the same time, right? Because you're only gonna get one of these as a result, okay? And so the events, at least getting a 0, a 1, a 2, a 3, a 4, a 5, and 6, they are going to be disjoint. Okay. Questions? Any questions on these? Okay. Experiment number 2. Experiment. How come I sort of get a feeling? Did we actually go over this before we went on a break? I sort of had a feeling that we've gone over this. We did. Okay. All right. So we did go over it. Right. So I think briefly, I think we went over the properties as well. So that's why it seems familiar to me that I feel like I've done this already, especially the next one, right? That's the one I was going to go ahead and do next, the 15-minute rule, right? Um, so an instructor is no more than 15 minutes late. Okay. And so x, okay, will take on values between 0 and 15. Right? The parentheses on 15 means it does not include 15. Wait a minute. It says no more than. So sorry, 15 is included. I bet. So 0 to 15. Okay. As far as inequality is concerned, that means x is between 0 and 15. Okay. Note this time, this variable is continuous, right? So this is not a discrete variable. This is a continuous variable, right? In the fact that you can have 5.5 minutes late or 6.2 minutes late. And so you are able to take on any value between 0 and 15. Okay. Questions on that? Any questions on it? Okay. Did we go over probability distribution? No. All right, so probability distribution. Okay. All right, so we talked about distributions before. What does it mean to have a distribution? Table, right? That's what it means, right? So I told you when we were talking about distributions before, distributions essentially means table, right? So that's why we had a frequency distribution, a relative frequency distribution, a percentage distribution, right? So distribution is a table. Whatever word comes in front of it essentially tells you what should be on your table. And so in this case, distribution means table, and what should be on my table is the probability. And so what's going to happen is you're going to list down all the possible values of x, and then right next to each one is you're going to have a the probability that each x is actually going to happen. And so that's what makes a probability distribution. um, so a quick example, right? So x, p of x, 0, 1, 2, 3, 4, 5, 6. So this is the probability distribution. And so I want to put the correct table on there. So this is the table. So 0.016, 0.094, 0.234, 0.312, 0.094, sorry, 0.234. 0.094 and then 0.016. Okay. So I wanted to give you an exact example. So I had to look this up, right? Because I made up the numbers over here. And so I want to make sure I have the right ones here. So this is the probability distribution for experiment number 1. Okay. We'll talk about how to find these probabilities later. Okay. So we'll talk about that later. But this is an example of a probability distribution, right? So I list down all the possible outcomes. Okay. And then you have the corresponding probability for each of those outcomes. So this is an example of a probability distribution. Okay. Questions? Any questions on it? Okay. Now let's talk about the properties of a probability distribution, right? So there is a properties that needs to be satisfied for your probability distribution to actually be valid. So properties of probability distribution. So the first one, okay, all your probabilities, and we saw this already from before, has to be between 0 and 1, right? So 0 is less than or equal to P of X is less than or equal to 1. So it has to be between 0 and 1 for all of them. Okay. All right, and then number 2, and again, since these are disjoint, okay, or at least these events, so which means these are individual probabilities, and so none of them overlap. And so the sum of those probabilities has to be 1. So double check and see that it is 1, right? So go ahead and add all the probabilities and double check that it is 1. I think I left my calculator over there, so let me go grab it. All right, so is the sum 1? I hope it is. Was the sum 1? Okay, just want to make sure. I might have copied it incorrectly, but the sum is 1. So this is a valid probability distribution. So for our next example, I'm going to give you some tables and tell me which one of these are valid probability distributions. Okay. So example number 2. All right. So determine if the following tables are probability distributions. Right, so does it look like there's an I there? Okay. All right, so example number 3. So x, p of x. So I have it 0, 1, 2, 3, and then 4. 0.04, 0.26, 0.36, 0.20, and 0.08. Okay. Number 4. So x, p of x. So 0, 1, 2, and 3. 0.125, 0.375, 0.375, 0.125. And then last, number 5. So 7, 8, and then 9, 0.7, 0.5, and negative 0.20. Okay. Now, if you're watching this on YouTube, this is where I actually pause the video. So you're going to have to pause it yourself. So that will give you time to actually work out each problem. But for the people sort of watching this live, just simply answer the question on your own notes first, and then type in your answer either on the chat, okay, or say it by unmuting your mic. But for you, if you're watching this on YouTube, pause the video, right? All right, so so let's talk about the answers, right? So is the first one a probability distribution? So someone said no, no. So the first one is no, and the reason for that is some of you were saying the sum was 0.94. So all the probabilities are between 0 and 1, but the sum of the probabilities is not 1. So which means this is a no. So this is a no. So this is not a probability distribution. How about number 4? So number 4 is a yes, right? So it is a probability distribution, right? So that is a valid probability distribution. Okay, and then last, number 5. So some say no, some say yes. So the answer is no on this one, right? So no on number 5. Okay, and the reason for number 5 is it fails the first property. So remember, all probabilities have to be between 0 and 1. Negative 0.20 is not between 0 and 1. So hence, this one is not a probability distribution. So it's not about just adding everything up and the sum should be 1. The other thing is that all probabilities have to be between 0 and 1. So that's why number 5 is a no. Okay. Any questions on that? Any questions on it? Okay, now the other thing on here is you're gonna have to keep in mind that X can actually be negative, right? So the value of your random variable can actually be negative. So it's okay for your x to be negative, but it's not okay for your probability to be negative, right? So we're going to actually see some later where the x is going to be a negative value. Okay. Questions on these? Any questions on it? Okay. All right. Now, once you have your table, then it's easy to actually find your probability because it tells you already from where to where or what the probabilities are for each one. And since each sort of outcome is going to be disjoint, then you should be able to answer probability questions pretty easily. So here's an example of what I mean by that. So this is example number 6. So this is a little bit different than the first previous 3 problems. So in this case, I have the machine sold. And the corresponding probability for that particular value. So I have 4, 5, 6, 7, 8, 9, and then 10. And the corresponding probabilities are 0.08, 0.11, 0.14, okay, 0.19, 0.20, 0.16, and then 0.12. Okay. Can someone check and make sure that this one does add up to 1? Okay. Let's double check, make sure that all my probabilities add up to 1. We don't want to answer a question if this is not going to add up to 1. Okay. So people say, yes, it is. Okay, so that means this is a valid probability distribution. So now I can answer probability questions based off of this, right? And then essentially you answer these questions by reading off your table and using some of our rules from chapter 5. And so question A, right? So find the probability that the number of machines sold is 7. And so as far as we're concerned, we are talking about probability that x is 7 or just simply probability of 7, right? So either notation can be used. Um, it is implied you only have one variable. So in this case, it's just x. And so x just has to be 7. And so what's the probability that you're going to have 7 machines sold? 0.19, right? So, and there is your answer. Okay. Question or part B. Okay. So let's do a little bit harder, right? So this is something we are gonna have to see quite a bit in our class. So something like this, more than 8. Okay. So now as far as notation is concerned, so more than means this time I have to use the first notation. I do have to put x on there. So I want the x to be more than 8. Now, as far as calculating the values, right? So this basically means basically more than, less than, at least, at most, no more than, or no less than. They mean or. So in this case, it's the probability that it's more than 8. So in this case, it's the probability that it's 9 or 10. So as far as we're concerned, it's the probability that x is 9 or 10 as far as our table is concerned. And since they are disjoint, this is simply the probability of 9 plus the probability of 10. 8 is not included because it has to be strictly more than 8. So it's just simply probability of 9 plus the probability of 10. So just add up the two probabilities. So 0.16 plus 0.12, and the answer is 0.28. Okay. Questions? Any questions on this? All right, so let's answer the next question. All right, so part C. Probability that it's at most 6. So first write it out as an inequality, and then write out the probabilities you're gonna have to add. Okay. You can do this because it's discrete. Okay. We're gonna have to talk about what happens if they are continuous, and that's gonna come in chapter 7. So at most 6 means probability that x is less than or equal to 6. And so that would be probability of 6 plus probability of 5 plus probability of 4. So it's the 6, the 5, and the 4. And if you add them up, you get 0.33. Okay. So now I want to at least write down some examples of, at least, more than, less than. So at least you have something to look at and how each one is sort of written. But any questions on this first? So problem number 6, any questions on that? Okay. All right, so I'm gonna go ahead and flip the page because I'm sort of at the end of that sheet of paper. Okay. All right, so some vocabs here, right? So in terms of symbols. So for this example, let's say x is from 0 to 7. I can certainly let x be any number I want between any value I want. I don't want to have too long of a number of values because I just want to go over the different words of what it means, right? So for probabilities like more than, less than, and so on and so forth. Okay, so let's talk about more than. Okay, let's use the same number here. So let's use 3 as sort of our value. So we'll talk about more than 3. Okay. So more than 3 means it's the probability that x is greater than 3. And as far as our values are concerned, that would be the probability of 4 plus the probability of 5 plus the probability of 6 plus the probability of 7. So that's what more than means. Okay. Less than 3. Okay. It's the probability that x is less than 3. So that means it's the probability of 2 plus the probability of 1 plus the probability of 0. Notice neither one of them includes the number itself. So 3 is not part of the probability if it says more than or less than. Okay. Questions on that? Okay. All right, now let's talk about the one that includes 3. Okay, so the first one says at least 3. Okay. So at least 3 means probability that x is greater than or equal to 3. So at least means it's the smallest you have. So 3 is the smallest, and then you go higher. So this would be probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 plus probability of 7. And then the counterpart of this one, it's at most, right, going in the other direction, that includes 3. Okay. So probability that x is less than or equal to 3. Okay. So this would be probability of 3, probability of 2, probability of 1, and probability of 0. Okay. Now there is another term that sort of uses it similar to at least and at most. Um, and so let me put it over here. So an alternate form of at least is no less than. So no less than 3 is the same thing as at least 3. Let me move so you can actually see the N on there. So no less than 3. And then at most is the same thing as no more than 3. Questions? Any questions on these? All right, now along with these, we are gonna be using your complement rules with these sort of vocabulary. So we need to talk about which ones are complements of each other. So we are gonna now talk about complements. So between these, right? So which ones are complements of each other? And so, for example, the complement of x greater than 3 is, don't put equals because they're not equal to each other. We're just talking about the complement relationship. So the complement of this is the probability that x is less than or equal to 3. So remember, it's directly the opposite. So it's basically all the probabilities not on this one. So not 4, not 5, not 6, not 7. So we are talking about 3, 2, 1, and 0. Same thing with this one. So the complement of x less than 3, its complement would be probability that x is greater than or equal to 3. So the complement will have the equals and vice versa. Any questions on these? Any questions on it? Any questions on this? All right, so it's about the perfect time to take a break, right? So this is typically when we take a break. So I'm going to go ahead and pause the video, and we'll take a 10-minute break. Okay, so again, if you're watching this on YouTube, it's up to you when you want to take your break. But for now, I'm going to go ahead and pause it. Okay, so we're back, right? So, all right, now the last thing on sort of this section is, aside from probabilities and see if a table is a valid distribution or not, would be creating your table yourself, right? So how do you create your own table? And so obviously the table just consists of making a list of all the possible outcomes. And then for each one, you have to find the probability. And so which means you're gonna have to be able to find the probability for each one. And so I want to sort of show you some techniques on how to do that. Okay, so again, a lot of these techniques involve stuff that we've done in chapter 5. And so, example, right. So direction is to create a probability distribution. All right, so the first one, probably the easiest way to do this, right? So example um, number 7. Okay, is sort of what we call using the law of large numbers, right? So if you repeat the experiment a large number of times, then you can use the relative frequency to approximate the probability that each one actually will happen. So the more often you repeat your experiment, so the larger number of times you run your experiment, then the better the relative frequency as an approximation for the actual probability. So suppose I have the following frequency distribution, right? So here I have sort of the number of classes a student is taking, and this is the number of students that sort of are taking those classes. Let's just assume that the lowest is 1. Okay, so we wouldn't have anyone taking no classes, right? So we only interviewed the people or the students that are taking classes, and let's say at most that most students probably will not take any more than 5. So 5 essentially is the maximum. So it's 1, 2, 3, 4, 5. So the number of students that are taking one class was, let's say, 75. Okay. The number of students taking 2 classes was 68. Okay. The number of students taking 3 classes was 122. Okay. The number of students taking 4 classes is 45. And the number of students taking 5 classes is, let's just say, 10. Okay. So note in this particular case, the total frequency, which is n, right, the sample size. And so if you add up everything here, the total frequency is what? It's 320. Okay. Now note, basically this 320 means you repeated this experiment 320 times. And so what is that experiment that you repeated? You ask a student how many classes they're taking. So that's your experiment. And so you repeated that experiment 320 times. And so this is a really large number, which means one way to create a probability distribution would be to use the relative frequency. And so based off of this, right, then you can now create an x and p of x, right? And so this is 1, 2, 3, 4, and 5. And the probabilities are simply the relative frequency. So if you've forgotten what relative frequencies are, it's basically the frequencies divided by your sample size, which is 320. So the first one is 75 divided by 320. So using your calculator, right? 75 divided by 320. And remember, I told you to always round to 4 decimals. And again, that would be clear on why in the next chapter. But for now, so this would be 0.2344. Okay. Now, you don't really have to do this or show this for everyone. You can just simply do it and write the decimal. So for example, 68 divided by 320, and that would be 0.2125. Okay. All right, so I'll give you some time. Go ahead and fill in the rest of the table. Right, so I actually wanted you to pause there. Right, so again, if you're watching this on YouTube, I want you to pause. So whenever I say and give you some time, it means pause your video. And so for the next one, I'm getting 0.3813. So some of you had the answers already. So it's 0.1406. Again, normal rounding rules, right? So, and then the last one is 0.0313. Hopefully those um, add up to 1. It might be a little off depending on the rounding. So let me just double check all our rounding real quick. So 45 divided by 320 is 0.1406. 10 divided by 320 is 0.0313. Okay. Um, Again, as I already mentioned, you might be off on your probabilities because of the rounding stuff. Okay. But if you kept all the decimals, it should have been 1. I think we're a little over, are we? Is it 1.0001 or something like that? Yeah, so we're a little over, and again, the reason we're over is because of the rounding. Okay, um, so if we kept all the decimals, we would have been really at 1. Okay, but since we didn't keep all the decimals, we were rounding, so the rounding gave us a little bit of an off. It's rare, right? Usually, some of them you round down, some of them you round up. Um, and so here, more of them was rounded up than rounded down. So that's why we have a little bit of extra, more than 1. But this is your probability distribution. So this is one way of doing your probability distribution, is using the relative frequency. Questions? Okay. All right, well, what happens if you did not run your experiment a large number of times, right? So what is another way of finding your probability? And so example number 8, okay. And again, that's what chapter 6, sorry, chapter 7 will be about. Oh, sorry, that's chapter 7. Sorry, 6.2 would be about. It's sort of giving you another way of finding your probabilities. Um, um, for finding your probabilities on your table. The question was, do we need to change them to equal to 1? No, really, there's nothing to change. The only way to really get you all out up to 1 would be to keep all the decimals. But it's rare. More often than not, some of them you round up, some of them you round down, and it balances out, and you usually add up or get up to 1. So that's why I had to double check all my rounding to see if they were all correct, and they seem to be all correct. So, so that's why we just had to leave them as more than 1. Questions? Okay. All right. So here's another method that you can use to do this. So this one, it would be the sample size would be small, so which means you cannot use the relative frequency to do so, but you'll have sort of a way to find your probability using some of the stuff we learned in chapter 5. So for example, here, so 60% of all students, okay, suffer from math anxiety. The 60%, I just made that up, right? Um, so if you're wondering where I got the 60%, I just read a textbook and that's what it says. Okay, so but it is given, right? So the 60% is given. Okay. So selecting 2 students. So which means my sample size is small, right? So there's only 2. So I cannot use relative frequency on this one. So selecting 2 students, okay. Let X be equal to the number of students with math anxiety. Okay. So create a probability distribution for this one. So I'm going to go ahead and put the table over here. So I'm going to have X and P of X. So first thing I want to do is list down the values for X. So what will be the values for X on this one? It's not just 1 and 2. 0, 1, and 2. Right? Because it is possible that neither one of them have math anxiety. Okay. So now the question is, how do you get the zero probability, right? So, or the probabilities for each one. Now, since there are only two values here, you can actually use some of your properties to help you do so. So, what's the probability that they both don't have math anxiety? Well, that would be 0.4 times zero point 0.4, right? So no math anxiety for the first one, no math anxiety for the second one. So 0.4 times zero point 0.4 is 0.16. So 0.16 goes over there. Now the other one that's easy to find is the 2 one, right? So the 2 one is they both have math anxiety. So that means 0.6 on the first one, 0.6 on the second one. So that means this is 0.36. And so this would be 0.36. Well, how do I find the 1? Now, the 1, by the way, is not simply zero point 0.4 times 0.6. Right? It doesn't work that way, okay? Because um, there's two different ways to get the 1 student. So that's the correct answer. Subtract, right? So remember, the total probability has to be 1. And so add these two and then subtract from 1, and the result would be 0.48. So this one, you can find it by adding 0.16 plus 0.36 and then subtract from 1. And so you get 0.48 as a result. Okay. Questions? All right, now you might ask, what happens if there are 2 things missing? Or what happens if there are 3 things missing? So for example, instead of 2 students, I was selecting 5 of them. So there are 5 students that I was selecting. So which means the outcome for X is 0, 1, 2, 3, 4, 5. I know how to do 0. I know how to do 5 because it's basically the same thing as these two. So now how do you find the middle ones? Now this is where our stuff for 6.2 is going to come in. So 6.2 will help a lot on how to fill in this table, okay? Especially on these kinds of problems, okay? But any questions on this? Any questions on this? Okay, so sort of the last topic. So this is like the second to the last. The last one again still involves probability distributions. Um, but let's look at an example on this one. So this one, I actually want you to create a probability distribution for each one. So example number 9. Okay. So this is the roulette example. So I know not everyone has played roulette, but I know most of you, if not all, have seen what it looks like, right? So that's the one where there's something that's spinning, and the it's not really called a dealer, but Let's just say the dealer will throw a ball, and then the ball will spin around and then eventually land on a number. Those numbers have colors on them. So some of them are red, some of them are black, and I think there's a couple that are green on there. And so that is sort of how roulette works. And then there's sort of like different bets you can make. So you can bet that a certain number will come out. You can bet that red will come out. So what it means come out means the ball is going to land on that particular thing. So if you said red will come out, that means the ball is going to land on a red number. Um, if you say seven will come out, you're saying that the ball will actually land on seven. And so these are sort of the different bets on a roulette. So one of them is what we call a number bet. So you are betting that a certain number will come out. So meaning the ball is going to land on a certain number. So on a number bet, you bet $5. Okay. And there is, okay, so bet $5 and there is a 1 out of 38 probability because there are 38 numbers on the roulette. Only one of them um, is a certain number. So in this case, there is a 1 out of 38 probability um, that a number 7 will come out. Now, if it does land on 7 and you put your $5 on there, you are going to win $175. Now, obviously, if it doesn't land on 7, then you're going to lose the $5 you bet, right? So that's how betting works in a casino, right? So you put your money down, and if you didn't win, the house takes your money, okay? So this is a number 7 or the number bet. Now, there's another kind of bet, which is called an odd bet. So you still bet $5, right? So we want to keep it consistent. So you are betting $5. And this time there is um, an 18 out of 38 probability, okay, that an odd number will come out. So it's there's an 18 out of 38 that an odd number will come out. Now the reason it's only 18 and not exactly half, there's a couple of zeros on there. There's 1 0 and there's a double zero, and so that's why there's only it's less than half. Okay, but there probably the win. When this happens, you only win $5. Okay. So now I'm gonna give you some time, and I want you to create a probability distribution for each one of these. Okay, you can leave your probability in fraction form because there's only two outcomes, right? So on both cases, there's only two outcomes: you win or you lose. Right? That's you either win something or you lose something. Now you cannot let win and lose to be your variable, right? So your variable cannot be win or lose because we are talking about discrete random variables. So they have to be numerical. So in this case, let X be the amount won or lost. If you lose it, then it will be negative. If you win it, then obviously it will be positive, okay? So I want you to create a probability distribution for each one of these. I'm gonna pause the recording. Okay, so I'm gonna go ahead and put my table on the side right here on the margins. All right, so for the odd number, again, there are only two outcomes, right? So x and p of x. So let x be the amount you won or you lost. So if you win, how much do you win? Correct, right? So it's 175. It's up to you if you want to put the dollar symbol in front, but 175 is perfectly fine as long as you know what the values represent. So 175 is winning, and then losing. So how much or what's the value when you lose? It's -5, right? So it's -5 if you lose. Okay. So now what's the probability of winning then? And again, I told you leave it as a fraction on this one. Okay. So the probability of winning is what? It's right here, right? So it's 1 out of 38. Now, the reason we're leaving it as a fraction is because we're going to do something with this in a bit. Okay. But for now, you can certainly use the decimal value, but I'm going to use the fraction for now. It's 1 out of 38. So now what's the probability of losing then? Remember, use your complement rule, right? So remember, there's only two outcomes. So that means the other one is strictly the complement. And so using fractions, then the other one would be what you need so that it adds up to 1. Well, it would be 37 out of 38. Right? Because right now, when you add those two, so 1 plus 37, you get 38 over 38. And then you have a 1 as a value. Okay. So that is your probability distribution for the first bet. Okay. Any questions on these? Any questions? Okay. Now let's do the other one. Okay. So on the other one, right? So let's create a table. So x, p of x. So if you win, how much do you win? It's 5, right? And how much do you lose? -5. What's the probability of winning? And it's on the table, or sorry, on the problem. So this one is 18 out of 38. And then the probability of losing, same thing, right? So it's your complement rule. So what do you need so that these add up to 1? Well, since the denominator is 38, then it's 38 minus 18. It would be 20 out of 38, right? So you want to add them so that the numerator adds up to 38. So you get 38 out of 38. And so that is your probability distribution. Questions on that? Any questions on it? Okay. All right. So now this topic, right? So something I could be asking you right here, right? So something you might be interested in, especially if you're the one gambling on this one. You might want to ask, which one is the better bet? So which one's better, right? So if you're gonna go gamble $5, which one is the better bet? Okay. So one way to sort of answer that question is to find what we call the mean of a probability distribution. Okay. And then there's also a standard deviation for a probability distribution. And the formula is as follows, right? So the mean for the probability distribution is the sum of x times p of x. So multiply the x times your p and then add them up. By the way, the symbol for this is the mean and then subscript x. So it's the mean for your x. Now the standard deviation for your x, okay. Since there's no square, I have to take a square root, right? So you saw this on your first test, and it's basically the sum of x squared times p of x minus the mean of x squared inside the square root. Now, as sort of what we've seen before, right? We obviously use our calculator to find both mean and standard deviation. So we need to talk about how to put this on your calculator. And so the idea is, so the x has to go to L1, and the p of x has to go to L2. Okay, and then you do one variable statistics, L1 comma L2. So this is the calculator instructions. So to answer the question, which one is the better bet, go ahead and find the mean and standard deviation for each one. By the way, you are allowed to put fractions on your calculator, right? So um, here's an example. So let me put it here. Can you see? Okay, maybe that's not the right calculator. Let me use my other one. That one has more light on it. I think this might be better. There you go. All right, so you go to stats, right? So stat is where everything is at. You have to go to edit. Okay, so I need to clear some stuff here. So clear, clear. And so for the first one, it's 175 and then -5. Now, keep in mind, this is your negative. This is your subtraction. Do not mix them up, right? If you put this on there, your calculator gonna tell you error. So this is your negative symbol right here, right below the 3. Okay. So you press -5 for that one. And then your probabilities. So this one is 1 divided by 38, right? So I'm putting fractions in there. And then 37 divided by 38. And then my calculator will automatically change them to a decimal. And then now, second quit. And then you do one variable statistic. So you go to calculate, and then second L1, comma, second L2. Right? And then since we are talking about money, right? So there's my mean. There is my standard deviation. So since we are talking about money here, so the mean is both money and the standard deviation is both money. Let's round to 2 decimal places. So on here, the mean for the first one. So for the first bet, the mean was negative 0.26, and the standard deviation is a 28.81. Okay. So I want you to do this on the second probability distribution. Okay, so for the next one, check and quit on this one. So stat, edit again. So I do have to change the 175. So the 175 now just becomes 5. The other one is -5. The first probability is now 18 out of 38. Right? And then the other probability was 20 out of 38. Right? And then quit to get out of the screen, and then do the same thing again, right? So one variable statistic, L1 comma L2. And again, L1 has to be X, L2 has to be P of X. Otherwise, then what you put on there will have to be the proper order. So the first one should be your X, the second one should be your P. Okay. And so now that means this one, the mean is negative 0.26. Okay. And then the standard deviation is a 4.99. Questions on that? All right, now let's talk about what exactly the mean means, right? So what exactly is the mean aside from the average? So the average or the mean is also called the expected value. Essentially, it's what you expect the value of X is in the long run if you keep doing this experiment. So which means on uh, the first probability distribution, you expect to lose 26 cents every time you make this bet. So you are going to lose 26 cents um, every time you make this bet. That's what your expectation is going to be. So now, which one is the better one? Well, you cannot use your mean on this one, right? So because you are in the long run gonna lose the same amount. Okay. Now, then you have to use your standard deviation to sort of help you out on this one, right? So again, there's less variety or variation on the second bet than it is on the first one, right? So the first one has a bigger range of values. Um, so you are gonna have sort of more variety or more chance of losing than it is to win. Okay, but keep in mind that if you did win on the first one, you might want to stop. Right, so once you won in less than maybe 38 tries, then you should stop, and you're basically gonna come out ahead. Um, Here, though, you tend to lose less often, but you also tend to win just a little bit every time out. But that means there's less variety on this one. But in terms of which one is the better in terms of expected value, neither one is better, right? So you expect to lose the same amount every time you bet $5. And by the way, I think none of the casino games have a mean of that's positive. So I don't think any one of them has a mean that's positive. They're all gonna give you a losing mean or a losing expected value for each game they actually have. Okay. Any questions on this? Any questions on it? Okay. I don't think we can start chapter or 6.2 on this one, especially if I am gonna record, right? So it's kind of hard to pause and start it again on a different day. And so I'm gonna stop the video right here. So again, we'll probably finish 6.2 and 7.1 on Wednesday. But 6.2 is the only one on test 2. 7.1 is not until test 3. And so, but we are going to start it, or we have to start it. We'll probably do 7.2 after spring break, or after, not after spring break, after our second test, because it's a pretty long topic. We might do half of it on Monday, and then the other half would be after the second test. So your second test is next Wednesday. Um, so for now, it's gonna be held during class time, right? So the test will be available on Canvas, and so it will have a time that's gonna open. So it's gonna open probably at 7 o'clock, and then you'll have until essentially 8:50 to finish your test, and then you're gonna have to upload your test. By that time. Again, it's pretty similar to the first test, um, except probably you're going to have to just show your work on a separate sheet of paper unless you want to print out your test yourself. I don't think I want to do that because I don't know if everyone has a printer. And so what's going to happen is that your test is probably maybe 1 or 2 pages only, and because there's not going to be any space on there. So all your work will have to be done on a separate sheet of paper, and then that's what you turn in and upload on Canvas by the time the limit sort of expires. And so again, make sure um, you're here during class time, right? So it's from 7 to 9 p.m. or 7 to 8:50 p.m. There is a time limit for your test, right? So it is going to have to be done by a certain amount of time. I may give you maybe 15 minutes or 20 minutes after so that you can upload your test afterwards. Um, but again, there's going to be a time limit, right? So there is a time limit to do so. And the reason for the time limit is because since it is done at home, um, I expect you, or sort of, I do sort of expect that some of you will have your textbook with you, some of you will have your notes with you, and so again, for now, for now, it's going to be fine. And but that's the reason why there's a time limit, is because it sort of forces you to study a little bit, right? So you're gonna have to study, and not just rely. Oh, I have to look this up on a textbook, because if you do that, you are going to run out of time, right? So if you do that and just sort of not study and just, oh, look it up, or what kind of problem is this? I want to see what it is on the textbook or in the notes. That's going to take forever, right? So it will take you longer to do that, and that's why there's a time limit on your test, because I still expect you to study for your test and not just simply always refer back to your textbook. And that's why your test will have a time limit on it. Now, speaking of your tests, based on the amount of holidays, cancellations that's happened, I don't think we're going to have time to take 4 tests. So I don't know if we're going to have time to take 4. So what's more likely going to happen is we're only going to have 3 tests, and then we'll have sort of whatever comes after the third test would be sort of new stuff for your final. Okay, and so it's probably just going to have to be 3 tests, and then your whatever comes after the third test would be the new stuff on your final. Okay. Any other questions? Okay. So let me go ahead and stop this recording.